This program creates an interactive polygon editor inside your web browser. Its main job is to let you draw a custom shape by clicking on canvas element to place points close that shape and then tweak it by dragging those points around. To demonstrate that the canvas is a dynamic and arbitrary workspace, the implementations allow you to reposition and resize it directly. All of this is drawn onto a single HTML canvas element, which acts like a dynamic programmable drawing board. The HTML and CSS are intentionally very minimal. They just set the stage by creating a duck page and placing the canvas on it. The program's core functionality, processing user input, managing state, and rendering graphics, is implemented entirely within the JavaScript. Let's break down the JavaScript function by function. The sys object serves as a centralized state manager and configuration hub for the entire application. Its purpose is to encapsulate all mutable state, key thresholds, and Boolean flags into one single predictable location, preventing variables from being scattered throughout the global scope. The philosophy behind this design is one of explicit state management, but by collating everything from the current mouse position and drag deltas to operational flags like is dragging canvas or is polygon finished. The object provides a snapshot of the program's entire operational status. This approach simplifies debugging, as all interactive state can be inspected at once, and streamlines function signatures by eliminating the need to pass numerous individual parameters. It acts as an application's control panel. The handle mouse function is the central nervous system of the entire program. Every time you move or click the mouse, this function gets called. Its job is to gather crucial information like the current mouse position and how far it has moved since the last click, and then delegate the specific work to two other specialized functions, one for managing the canvas and one for managing the polygon's vertices. Finally, it always calls render to redraw the screen, ensuring what you see always matches the program's internal state. The handle canvas function is responsible for all the interactions with the canvas box itself. When you move the mouse, it calls set cursor style to figure out if you are near an edge or corner, and changes the cursor icon to what action like resizing or moving will happen if you click. If you click and drag, it uses the initial state of the canvas, stored in the clone, to calculate its new position or size based on your mouse movement. The actual resizing is handled by small helper functions, like nResize and eResize, that adjust the top position and width respectively. Its partner function, handleVertices, manages everything about the polygon's points. On a click, it adds a new vertex and the mouse location but first it checks if you are clicking close to the first point, which is how it knows to close the polygon. As you move the mouse, it constantly checks the distances to every vertex. If you are close to one, it changes the cursor to a pointer and remembers which vertex you are hovering over. If you press on a vertex, it grabs its initial position and sets a flag saying a drag has begun. While dragging, it updates the vertex's coordinates by adding the mouse movement delta to that initial position. The render function is responsible for all output to the screen. It clears the canvas and then redraws the current polygon and all vertices based on the latest data in the vertices array and the sysState object. It executes on every mouse event, ensuring the visual display is always synchronized with the program's internal state. A few key utilities make this all work. setCanvas is a simple function that updates the canvas size and position of the page. Local mouse coord is essential for translating the mouse position into coordinates relative to the top left corner of the canvas itself. Finally, the setCursorStyle function uses a prioritized list of rules to decide what the cursor should look like based on its proximity to the canvas edges and corners, providing that intuitive visual feedback. The provided code is heavily commented to serve as a direct learning reference. This implementation leans into the use of God functions, like handling mouse down, tracking mouse move, and culminating in mouse up, is a single narrative. Forcing that narrative into dozens of separate ravioli functions can fracture the story, making it harder to see the entire process at a glance. To put it out simply, you can understand the entire interaction by reading one function. Furthermore, the architecture allows for straightforward modification, enabling features like vertex deletion, style changes, or serialization of the polygon data. This project demonstrates the core techniques required to build and manage interactive graphics applications. The link to the file location is in the description. Let's scan the implementation. That's all from my side. Be well.